everybody. Uh-oh. Got it. Hopefully my GPU will survive this encounter. It may not. Sorry, everybody. Give me a minute. Yeah, maybe. Okay, good. Let's go to the notebook then and hope for the best. Okay. All right. Hey, everybody. Welcome to our session on using SLURM effectively. It's sort of a basic how-to guide of how to use SLURM. I know probably a lot of you are already familiar with some of the more commonly used commands, but we're going to show off a few that'll help you. We're going to talk a little bit about how to use srun, how to use sbatch, when to use which, maybe a little bit. We're going to talk about looking up old jobs with saccount. We're going to talk about sq, scancel, right? Canceling jobs, looking at the queue and what's in the queue for you. We're going to talk about, what was the other thing? SEFF. Some folks like to say Ceph. I like that one too, but it does get confusing because we have a different Ceph as well.
Yeah.
But anyway, SEFF is S efficiency. So it's a quick and dirty script that tells you real quick a general idea of what your job's memory and CPU utilization was and things like that. So that can be useful for optimizing your own stuff so you can get through the queue faster while still having enough resources to do your task effectively. So we'll talk a little bit about that. We'll talk about sbatch arrays and how to request GPUs because it's a little bit different from other flags. And so that's just giving you a general overview of what we're going to do. Hopefully everyone was able to obtain, if you want to follow along at home, there is a notebook. I think that was in the session mail. So I hope you were able to get to that and get it and get a job started on Jha. If not, feel free to go through it at your leisure later, get it set up now. You can always join a little late. But I think with that, we're gonna get started.
Yeah.
So very first thing, just really easy. The very simplest way to run a job on Jha is just hello world and srun. So let's run it. So before we get started, I just want to say this little exclamation point tells Python run what comes after on this line.
What's going on with my account?
So we'll execute this in the terminal, like if we were in the terminal instead of in Python. And so we're going to make extensive use of that, and we'll see another one in just a second.
And we are using this as a Jupyter Notebook in the on-demand interface. So everything is running on Jupyter in the background over here.
Yeah, I'll try.
If you guys are familiar with it, if you just go to rc.ub.edu, you get to the on-demand session. And then from there, you can choose an interactive application and choose Jupyter Notebook. And once you're there, after following all the instructions of how you can download this repo in your profile, then from your Jupyter Notebook, you can go and open up this.
I can show that off really quick. So if you come over to interactive apps and you go down to Jupyter Notebook and you point the -- notebook dir equals wherever you put it. In our case, it's in the user data. My case, it's in the user data folder. I have it under repos. That's where I put all my repositories. And then how to SLURM. And you might have a different folder structure. You'll also need to make sure you have, do you need this one, the module anaconda? I don't think that's just there from earlier. Don't worry about that. You'll need to set a number of hours, partition, one CPU, maybe a few gigabytes of memory, and then click launch. And when you do that, I'm going to do that really quick. It takes you to the My Interactive Sessions page, and you can see this is the one I have currently running, and this one's waiting to run. When it gets to this stage, you can go ahead and click this button here, and when you do, you'll be taken to this page. It may not work at first. It may tell you it failed to connect. That's because after we started the job, we still have to start the Jupyter server, and that usually takes about 15 seconds or so. So you may have to try a couple times. Eventually, you'll get to a page that looks something like this, and then you can click on this notebook, and it will get you to here. And so again, to get that notebook, of course, you're going to have to go to the GitHub link, download it, put it somewhere, and then point your notebook dir flag at that folder.
Yeah.
So as if you don't know what it hadn't already done it. And so I'm going to go ahead and run this again because it's so exciting. I click that button and boom, srun. And so the --pty flag tells it to run all the following commands at the terminal. So I know it's confusing because the exclamation point says Python, run this at the terminal. but then the --pty tells srun, hey, run this stuff at the terminal. And so it does. And we get echo hello world. And sure enough, the output is hello world, like you'd expect. And so srun's really great for doing quick jobs that are like a single line command. They're not as good if you're doing full-blown scientific research, because they're a lot harder to keep track of how you've made changes. They're harder to collaborate on other people, or on with other people, things like that. So it's my preference, and I know a lot of other people love when they switch over to use sbatch instead of srun. So we'll talk about that in just a second, but how to use it. What was I going to say? With sbatch, of course, with srun, you can't run array jobs. So if you have, you want to run 1,000 data sets or different images that are all basically the same thing, and you want to run the same workflow on each of them, you'd have to type the srun command 1,000 times or build a script to run it for you. Sbatch can handle that internally using the -- array flag, and we'll see that towards the end. But sbatch makes it a lot easier to share with collaborators, keep track of your versions using Git. It's easier to read and modify in your favorite text editor. You can't really read an srun script very well in your text editor because you're typing it at the terminal, unless you wrap it in a bash shell script. But why are you doing that instead of using sbatch? So, which is the same thing, but easier. You can run multiple commands in the same job, like on separate lines, in a row, in a sequence. Run many of the same type of job with a single submission with arrays. And it won't, most importantly, perhaps for a lot of you, is it won't terminate if your terminal loses connection. It won't end. So if you're running an srun command and it's long running and you're waiting and you lose a connection to Chiha, that sends a kill signal to the job and the job ends. But if you're running sbatch, it runs it in the queue in the background. And so if you disconnect, it continues running even if you disconnect it. So prefer sbatch, except for just quick and dirty tests or simple things. So let's see a hello world in sbatch. So it's going to be a little bit more intricate to write, but so you can see there's this sample script down here. I'm going to skip most of the text because we'll talk about it. But this %% bash is a lot like the exclamation point, but it's a Jupyter magic instead of a Python command. Basically, it says, I want this entire cell run using bash. Yeah. Right. So send all of these lines to bash as a single thing, a single unit. And so then this cat left EOT is the start of what's called a here doc. And it's basically everything from this EOT, or everything after this line that the EOT is on down to this EOT, it's going to cat this all to the file hello world.shell somewhere on your I guess in the folder that this Jupyter Notebook's running in. So if we press run, you're not going to see anything interesting happening, but we can verify that the contents are there by using shell cat back to us, right? And so we're going to cat that file back to the terminal. So if I run it, hey, look, you can see that, right? There it is. So it came, we pulled it out of the file and we wrote what we thought we wrote. Give me 1 second. I'm gonna, oops. I realize I have all of my outputs up, so I'm going to go ahead and do that. So let's rerun here. And if, okay, there we go. So now that we're sure that our hello world shell file is prepared the way we expect, right, we can submit the script to the SLURM queue using the sbatch command. So we're going to go ahead and, just like srun, but with sbatch, there is no --pty involved. It just assumes everything in this script that isn't a comment is going to be what you want it to do, i.e. the payload.
Yeah, and you already specify generally at the top of the file what kind of shell you're looking for. So,
right. So that's the #bang/bin/bash. It's saying run this with bash.
Right? Yeah.
And then of course you've got flags. So you want to talk about flags a little bit, Ravi?
Yeah. So I'm guessing a lot of you might already be familiar with most of these flags. Job name generally specified, well, basically #sbatch, whenever you have it in the job script, that's a SLURM directive that you're specifying in the sbatch. So whenever it sees #sbatch, the scheduler, it knows that you're passing in some metadata information about the job, and it's not an actual task that it needs to run inside the job. So you specify #sbatch, and then you have job name. It knows that the job name is going to be called this. And the second one is output. This is generally standard output.
Mhm.
And %x is, I believe,
Sub in the job name. So
Yeah.
whatever you gave as the job name, it'll put that in the place of %x. So in this case, job name's hello world. So it's going to replace %x with hello world, literally, when it goes to write this file later.
Yeah.
And I like to make my output and error the same because I don't care to separate them. Some folks have different workflows. If you have a workflow where the error has anything in it, which is maybe more typical workflow, it says stop what you're doing. That might be where you have them be separate files, for example.
Yeah. Yeah, and then you have the resources section. Again, you still have to specify the hash batch because for SLURM, everything remains the same. And then you specify which partition you want, and the partition and time are very correlated, at least presently in our SLURM definition. So there is a limit on when you should use express partition. So if your job is going to run for 2 hours, then you're using express. If you're using it for 12 hours, it would be short, and so on and so forth. Generally, you can find that information in a lot of places. You can take a look at our docs wiki and search for SLURM. You should be able to find what are those partitions and corresponding time, or what is the time and corresponding partitions. And your on-demand dashboard has that information, and all the other places. N tasks equal to 1. N tasks is generally very useful when you have some MPI application where you can specify multiple tasks that can define.
You have your
workers and do their work and stuff.
What? How did you switch it on?
And then there is CPUs
just plugging the cable,
and then the mem that you're specifying. CPUs per task is basically how many CPUs you require per task. And since we were only asking for 1 task over here and 1 CPUs per task, that means for the entire job, we are asking for 1 CPU. And in the mem, we are specifying what's the total memory required for this job, 256 M. There is another parameter called --mem per CPU. And in that case, if you had specified 256 M and you had asked for 4 CPUs per task, then you would have asked for 4 into 256. So 1 gigs of RAM in that case.
Right. So if we were to replace this mem with mem dash per dash CPU, then like Ravi said, that if you had 4 CPUs, it'd be 1 gig total. This is what trips up a lot of folks who are new to SLURM, is you have to do a little bit of your own math to figure out what resources will be actually requested by SLURM based on the flags you give. I kind of look at NTAS as like a bookkeeping thing. It just says, I want to do one thing, right? And for each one thing I want to do, I want 1 CPU. So in this case, I am asking for 1 CPU total. If I had 2 tasks and 4 CPUs per task, then I would need 8 CPUs total. Same for mem, right? Mem, just -- mem by itself means I want this much memory per node. So if you're doing a single node non-MPI job, that's just how much memory you're going to get. If you do an MPI job, then you're going to get that much on each node that you ask for. So if you say you want 3 nodes, then you're going to get a total of 3 times the memory you say in mem. And like Ravi said, if you do mem per CPU, then you have to multiply CPUs per the CPUs you get by mem per CPU to get the total memory you're requesting. So if you know you need 32 gigs and you know you need 4 CPUs, you could request it this way: 4 CPUs per task, 1 task, and 32 gigs mem. Or you could say 8 gigs of mem per CPU, and then 8 times the 4 CPUs you had would be the 32 gigs you know you need. So often we don't know these numbers. We know what we need in total. At least that's how most folks think about computing problems before they become really up to speed on the Chiha side. So you have to kind of do your own math to back out what these numbers are.
Yeah. And after that, you're just running what you actually wanted to run in the job. So before this, everything with #spatch is a directive that you're giving to SLURM that, all right, this is my metadata information. This is how I want the job. These are the resources that I'm requesting.
Exactly.
And but the actual job that I have to do, that's basically sleep for 15 seconds and echo hello world and hi again. By the way, the method of using cat to write the JavaScript, that's so because we are in a Jupyter Notebook.
Yeah, that's only because we're in a Jupyter Notebook. You could go ahead and write hello world.shell directly in your own file system if you want to, or whatever script you're doing. You don't have to do all that cat stuff. Again, that's just for this, just for getting everything into this Jupyter Notebook without needing any other files. That's the only reason I did that. Yours would, you'd go into your file system, you'd use gedit or VS Code or whatever your favorite editor is, and you literally write a file that looks like what you see here. You literally write this stuff, not with all this extra bookkeeping. Okay. Just to be clear, thanks for that, Robbie. That's good. Okay, so, and the reason I put 15 seconds of sleep is because we're going to go through the next few steps, and we want to see what it looks like in the queue. So I'm going to go ahead and run this. And if you see, I've submitted batch job, and then this number is your job ID. And that's very useful, and we're going to keep that in mind for later. And I'm going to go ahead and run SQ, so you can see, hey, I've got my 2 Jupyter jobs, the one I'm using and the one I created to show you how to do that. And then also, if you'll notice, the 105.97895, 105.97895. So there we are. And it's been running for 10 seconds as of when I clicked it. And I'll bet you if I do it again, it's gone, because 15 seconds later, it prints pretty much instantly and your job's done. So it's out of the queue. Okay. And now we're going to say, remember, we printed to %x.log. %x was the job name, hello world. So we expect there to be a hello world.log file now in the same folder. So we're going to run, and hey, there it is. I catted it to the terminal, and it says hello world, hi again, exactly what we expected based on our echo statements.
Yeah, we only had 3 commands, and sleep doesn't have any standard output or anything. It's just sleeping.
It's just sleep for that many seconds. So, and so now you know how to use the workflow for using SBatch scripts, right? You know how a little bit about how to write them. You know a little bit how to see how they're doing in the queue, and also how to look at the output. You don't have to use cat, of course. You could do this in your favorite file editor or in the file browser in OOD, any number of ways, whatever you prefer. Okay, so I'd like to talk about some good practices briefly. So I like the Zen of Python. One of my favorite things in there is explicit is better than implicit. And the reason they say that is because often we'll write code and then we'll walk away and work on another project and come back 3 months later and look at our code and go, what the heck did we mean? And if you do a lot of things implicitly in your code, right, you're not going to remember what those are. So explicit is better than implicit because it helps you remember what you did and it helps other people understand what you did. So for an SBatch script, don't rely on the default values unless you're sure you're not going to change them. So you should pretty much always be giving your scripts a job name. It's 1 extra line. It takes you a few seconds. Give it a job name. That way you can differentiate it from the other jobs you might run on different projects or other parameter sets or any number of other things. So always give it a job name. That way you know what you're looking for. Always specify an output and an error log. They can be the same thing, like I showed you. They can be different, but always do that, because otherwise you're going to get a default of slurm-job ID number.log.
Yeah.
And it's hard to comb through those, right? If you give it the %x, you know what to look for.
Especially if you have submitted like 1,000 of the same jobs, it would be difficult to go in and find out which job failed and how to actually go and find that. So.
Yeah, so it can be tricky. And then of course, make sure you choose your partition. I don't even know if there is a default partition. I think you have to. Make sure all of these resources are selected carefully and intentionally. If you're new, sometimes making that intentional choice can be difficult. We can provide some advice in office hours and things like that. But I generally like to think of it, new users tend not to want to conquer the world immediately, right? And most people don't try new things that way. So my recommendation is go with that. Try running it like it's a desktop. Ask for 4 CPUs, ask for 32 gigs of memory, ask for maybe 1 GPU, and just try. Right? Give it a test case, give it a test run, see what happens. And then later we'll talk about SEFF and you can see, well, did it use that much? Was it saturating those CPUs in memory? Or did I get a out of memory error? And then maybe double the memory and try again. And then you look at that SEFF, it'll say 60%. And so you say, oh, okay, so I know I need like 48 gigs instead of 64 gigs.
Yeah.
Right. Yeah. And we'll talk about that more carefully in a minute. But definitely, be thinking about how to choose those numbers as you go forward. It'll help you, it'll help everybody else. If everybody else does that, the queue goes a lot faster. So
yeah, and you get your job a lot faster.
Exactly.
So like if you were just using 2 gig and you only need 2 gigs for your job, but you ask for 100 gigs, the SLURM scheduler is going to have a difficulty finding 100 gigs for you compared to 2 gigs or 3 gigs.
And even when it does, you're going to be lower priority than
Yeah.
than like an 80 gig job, for
Yeah.
example. So it's something to think about.
Yeah. So you're not sitting in the pending state for your job, and you can get out of the queue faster. It's always prudent to find what's the ideal balance between that. You don't want your jobs to cancel out because
They
of low
failed
memory
or
errors,
something.
but you also
But-
don't want to ask for that for so much that your job just keeps sitting in the queue forever.
Exactly.
So it has to be somewhere in the middle. It's generally, I say that if you know that your job needs some value like X value, then ask for 1.2 times X or something.
Yeah, exactly. Because you don't want it to be at 99% efficient memory. Because
Yeah.
there's a chance the next time you run it for some whatever reason, it asks it
Yeah.
the implementation changes of your code, and boom, it's 101%, and now your job's canceled
Yeah.
6 days in or something.
Yeah,
So
yeah.
You don't want that. So
I think 70%, 75% is a good.
it is a good
value.
target. Yeah,
Yeah.
75-80%. I think I agree with Robbie. Okay, so let's talk about how to cancel a job, because sometimes, and I think we've all done this, where we run a job with the wrong parameters, and now that job's going to run for 3 days, and it's like, it's just eating up resources doing something we know is valueless. So we're going to run the exact same workflow we did before. We're going to cat stuff to a file. You'll notice everything's the same except sleep 3600. Oops, I accidentally slept for an hour.
Yeah.
Okay, I meant to write 15 seconds, but I don't know that right now. I'm just letting you guys know. So I'm going to go ahead and run this. Oh, and you'll notice I gave it cancel me.shell, and the job name is cancel me to distinguish it from what we already had. We certainly don't want to override our old outputs, so we can review them later. Okay, so I'm running that. Okay, great. So we're going to make sure, or not running, writing to a file. So here it is. Okay, we wrote it to the file successfully. So this is what you would write if you wanted to write this job. I don't know why you'd want to, but so, okay, submitted the job. We got our job ID 105979767. Let's check the queue. Okay, there it is, 6 seconds in. So if we run it again, 11,
Yeah.
and then,
We were thinking of stopping it for 15 seconds.
and so I accidentally, yeah, no, we're good. All right, so, oh no, it's going too long. Okay, well, that's obviously we coded it wrong. So let's go ahead and cancel that job because we don't care about its output. So all we do is type cancel and then the job number, which I'm going to have to change. So it's 105979767 from here, right? Or from here. And so I'm going to go ahead and cancel that. Let's cancel that. Okay, so no error, so that's good. So let's SQ again. Hey, it's gone. Great. So we removed it from the queue. It's just instantly terminated and gone. So all those resources are freed up. Other people can use them. Your own other jobs can use them.
Yeah.
Your priority gets better because you're no longer using resources on the cluster, or as many anyway. Cancel is not really, particularly complicated thing. You, if I'm remembering right, you can do comma separated lists also.
Yeah.
So if you have like 5 jobs you want to cancel, you can write out a list of comma separated list of 5 jobs.
Yeah, and I mean, if these are the only jobs you have submitted, you can also specify yourself as a user. So cancel-u.
We're not going to run this
because
it will kill the notebook. But if you write it like this, it will cancel all of your jobs that are running. So we're not going to do that. That would be not good. 97967. Okay. All right. So I think that's enough about cancel. If anybody has any questions about anything we're talking about, feel free to speak up, type in chat, YouTube chat, whatever it is, and we'll help you out. Okay. So next up is how to review past jobs. Well, we just ran a couple of jobs, so why don't we go see more about them? So let's gather up those numbers, because I got to change this, right? So we have an S account -J for job number. So one is that one. If we go way back up, and you're going to want to play along. If you're playing along at home, you're going to need to do this too. There's no way I can get this automatically. Sorry. And even if I did it, I don't think it'd be as helpful as doing this manually, since a lot of the time you're going to be doing it manually, at least with S account and cancel. Okay, so if we run that, we can see, hey, it's a useful little table of information. We can see that our first job, the 7895, was completed. It used 1 CPU, and of course we can get lots of other outputs. We can show you that in a minute. And then the 7967 was canceled, as we expected. And so you'll notice each job has 3 lines. It's got the main job itself, like the actual job submission, and then different job steps. And I'm not sure, I don't remember what Robbie, you maybe can talk more about the batch and the extern, if you know.
Yeah. I mean, it's batches basically um,
The S patch.
yeah, the actual things that are running inside the job, and external, I think, I believe it's more about the metadata. I'm not 100% sure about that.
But it's a SLURM implementation thing,
Yes,
right? And
yeah.
so you'll always see these three for any job submission. You may see more if you are to run, and we can talk about this later, but in SBatch, you can sub-allocate resources using SRun, especially for things like MPI jobs.
Yeah.
And you can set those become job steps. And then they'll show up on this list additionally.
Yeah, but these three would always be there.
Yes.
Even if you don't have anything else. And I believe the second one is when things are running, and the third one is when they're allocating resources based on the metadata that you provided. Again, and it's just that I'm not 100% sure of that. So if anybody wants us to find that out, I can go ahead and find some information about that and send it to you guys. Send us an email or come to office hours.
Yep. And so there's also another course. I mean, and so this is one of the main ways you'll use SAccount. So you can kind of review your jobs. There are tons of output flags. We'll show you in a minute what a few of those look like. But another way you might look at it is, what jobs did I run between a certain date and a certain other date? And so -S or -- start date, all one word, lowercase, is anything since the starting midnight of that day, if I'm remembering right. So if you want to think about a 24-hour clock, 00:00.
Yeah.
Right.
Yeah.
So if we run that, of course, we'll see all the jobs I've run today. The two Jupyter jobs, we got this one, of course, running, and then the other one I used to show off the hello world and the cancel me. You can see I haven't been very busy on the cluster today. We can also look into the past. I think I did a few of these for practice runs before. So if we do 2021, I'm putting -E, --end date, and that gives you a way to terminate it so you don't look at the whole thing. And so I can run that, and it shows, yeah, a whole bunch of jobs. So you can see I was practicing a while back and ran it a bunch just to refine the script itself. So that's just to give you an idea. So the two main ways to access jobs are with the -J flag for specific comma separated job lists, or just a single one, and the -S-E to bracket a time and give you all the jobs in that time.
Yeah, and I don't think we have it over here, or it was intended for this class, but just to let you guys know, there are way more parameters that you can look at about a job rather than what you're seeing over here, like job ID, job name, partition. You can also see how many CPUs you asked for, how much memory you asked for, how much you actually used in the job, and all this. Oh,
in fact, I have a few here. Robbie's absolutely right. There's way more than this. It's like, what, 60 to 80 or something, like different flags you can look at. A lot of them won't give you any useful information, but at least these few I find are pretty useful. So you can get the job ID, start date, end date of the job itself, which it uses to determine the S and E flags, right? Whether it falls in that or not. What state it had. So we saw completed or canceled earlier. Allocated CPUs, we gave it 1 and 256 megabytes. N means per node, little n means per node. If you do it per CPU, it'll be a little C there.
Yeah, so this was how we actually requested the resource. We asked for just mem, so it asked it was like, all right, so this is how much memory you need per node. If we asked mem per CPU, then it would have given us MC, so max per core
or CPU. Yeah, and so we can also do max RSS, which is the maximum resident set size. Don't worry about the details too much. It's basically how much memory it used at most at any point during the run. So in this case, it used 1492K, which is about 1.35 megabytes or something like that, 1.4-ish megabytes, somewhere in that range. And so we are massively inefficient on this job. I mean, like big time, right? We use less than what, 0.5% or something. So, and so it's good. That's good that we're exploring that, right? And all our users, we encourage all of you to explore how efficient you're being with your jobs, because it takes us a little bit of time. And again, if you can be really efficient, like that 80% margin, your jobs will go through the queue faster because you're asking for less. And so I'm going to go ahead and show you off the SEF command, or the SEFF command. And so all you do is type SEFF and then the job ID number. And I'm just going to go ahead and click run. And this is from my old job ID. I mean, you guys can pick whichever one you want. And so you'll see CPU utilized nothing, 0% CPU. And of course, that's because all we did was run echo, right? How much CPU does echo use? I mean, it takes it a few, probably like a microsecond to echo that to the terminal. It's like nothing. And then memory utilized 1.46 megabytes. Oh, so I was a little off, sorry. 0.57% of 256 megabytes. So we could do a lot better requesting this job. We could have asked for 2 megabytes and we probably would have been okay.
Yeah, 2 megabytes and about like what we had, our sleep was for 15 seconds.
Yeah. So I mean,
we asked for how much time?
We asked for 1 minute. So we could have also been more efficient on the time request. I think right now time has, okay, the amount of time you specifically specify with the -- time flag has no effect on priority yet. I mean, we haven't, that's not a thing we've implemented. Instead, we've broken it up into partitions, and those partitions affect your priority. So whether you run a job for 1 minute or 2 hours, if it's on the express node, it will be as good a priority for you, a favorable priority for you as it could possibly be, regardless of what time you choose in that partition. But if you need 8 hours, you got to switch to short, and your priority becomes a little less favorable. But there's nothing you can really do about that. That we do that because we don't want people. Ideally, we don't want y'all creating these long jobs and then running a 5-minute thing on it. And then even worse, if it's an interactive desktop job and you leave it open for the entire week while you go on vacation or something, you know, that's resources that nobody else can use. So we like to, you know, make it try and push you down try and push you down on the time requirements as much as possible. So you can we're trying to encourage you to be as efficient as possible.
Yeah, Ceph is actually a pretty nice tool. It gives you a nice summary of how many resources you asked for, how much you used, and that does make your life easier the next time you're trying to. We always say that the first time you're trying to run a workflow, you're not aware of how much memory it's going to require, how much time it's going to require.
Exactly.
So at the first time, you're just trying out things so that you can figure out the best possible values for your workflow. And in those times, Ceph actually helps you a lot. Even in the future cases, once you have your workflow running and you submit like 100 jobs, it's easy to just go into Ceph and be like, all right, search through all these jobs and see if one of them was inefficient or anything, and see how you can optimize it so that your queue time is lower, or the amount of time you sit in the queue in the pending state is lower. But yeah, at least for the first run, Ceph is an excellent tool. So I would encourage everyone to just use this every time you're trying out a new workflow.
Yep. Yeah, and it's always good to have tools like this in your back pocket, because you know, optimizing your workflows it doesn't just save you queue time, it also could save you job time, it can save all sorts of things and make your life a little easier as a researcher. So
along with everyone else.
Yes, and I know everyone is looking out for number one, of course, right? Themselves. Everybody does that. I do it too. But it's also nice to remember we're part of a community of researchers, and that anything you do on the cluster potentially affects other users. We, of course, secure as much as we can. We encourage people to be as efficient as possible, but just bear in mind that what resources you use are resources other people can't use during that time. So please try to be as efficient as possible. It helps everybody. And then because you're doing that, you can expect everyone else to do that, and your life will be easier too.
Yes.
So, all right, so let's move on to Hello World with arrays. So I know Hello World, everybody loves Hello World, right? So, okay, so sometimes we want to run the same analysis on many of the same kind of data set. So I'm an image processing person. So, you know, you get 1,000 images and you got to process them all the same way. So of course you want to be able to run exactly the same workflow on the images the same way, but you also don't want to run it in serial on your computer, on your laptop or whatever. You want to run it with as many CPUs as possible, so the wall clock time will be shorter, right? If I ran it on this laptop with 4 cores, say 1,000, take 250 units of time, however long it takes to run one, right?
Yeah.
But if we run on Chiha, where you can potentially use up to 250 cores ish, then in that case, you could run it in 4 units of time, maybe 5 with some overhead, right? So, I mean, that's a lot faster than 250. But you also don't want to be typing SBatch scripts all over the place. You don't want to have to, I don't, maybe you do, but I don't want to have to mess around with bash editing variables and all this other stuff and building scripts on the fly and all that kind of thing. I'd rather just use something that's sort of built in for me. And that's where the -- array flag comes in. So we'll notice we're going to make a few changes. The first one is we're going to change the job name a little bit. We're going to put hello world array just so we can distinguish it from others. And we're going to change the output and error logs to be %x, which again is the job name, underscore %a. %a means put the array task ID here. So array task IDs, let's go ahead and go down to the array flag. That's the other one of the other things we added. So in this case, I'm saying run iterations or indices or whatever you want to call them, 1 through 4 and 10 through 12. And I want to run at most 4 at a time. And so these numbers, 1, 2, 3, 4, 10, 11, 12 are the ones that are going to get run. And %a is going to be replaced with that 1 log per array iteration. Okay, so I hope that made sense, right? So we'll kind of see it in action in just a minute. We also added, let's see. Yep. And the other thing we added was we're going to write hello world from, and then from number, and then I put slash cache slurm array task ID. The slash is so we escape this cache variable. So it makes it through, because we don't want to replace it right now in this script, which it will do without the slash. We want to replace it when we actually echo it. So the slash will go away when we get to that point, and it will echo the internal variable slurm array task ID, which is set to match these 1 per iteration. So 1, 2, 3, 4, 10, 11, and 12. So we should see each of those. So I'm going to go ahead and cat this. Oops, where am I going? I'm going to click run. And I'm not going to bother looking at it. I trust at this point that it's going to cat it to the file. I think you got the picture by now. Don't actually write all this cat EOT, blah, blah, blah. Just go ahead and write it directly in the file. And so we're going to go ahead and submit that. Oh, did I? Yeah, okay. And I probably should name the script a little different, but we can, maybe you guys can do that at home. Okay, so we have SQ-U user. So that's going to be all my jobs. We saw that earlier. Uh-oh, did it not go? Oh, it probably finished already. I probably went too fast or went too slow. I mean, so let's go ahead and submit it one more time. Okay. Yeah, there you go. So you're going to see 1, 2, 3, and 4 are there. And I'll quickly try and get, oops, maybe. Nope, I was too slow. Okay, well, trust me when I say that 10, 11, and 12 will show up there. And we can actually see that if I change this to 7.
Yeah, we can also add a sleep for 5-10 seconds.
True. You're right. Let's do that. Robbie here with the sensible ideas. Keep me on the ground. So thanks, Robbie. All right, let's see. We're gonna run that. And then we're gonna run this. Okay, go ahead. Yeah, now you can see all 7. So like I said, 1, 2, 3, 4, 10, 11, and 12. So all 7 of those task IDs are running simultaneously because we set that %7. If we set it to 4, of course, you'd see 4. So you'd see 1, 2, 3, 4. And then after they're all done, or as they go out, 10, 11, and 12 would jump in. And so, well, it's probably not done yet. Oh, no, it is done. Okay, good. So I talked on this. All right, so we're going to cat the hello world array 4.log. Okay, and so we see hello world from number 4. And if we switch this to 12, we should see number 12. And so each of them is going to have that slurm array task ID, which again is this these numbers here. And so you can imagine it kind of like a for loop. If you're familiar with programming, in a programming language, you have a for loop that has some iterator variable. A lot of people write I. Yeah. So this is, you can think of this as your I variable, or this as your I variable, the slurm array task ID, or in the case of the log name, the %a. Okay, and so you may be wondering, well, that's all great, but when the rubber hits the road, or as they say, or in other words, when you actually put this into practice, it may not be this straightforward to say get data out of a file. And so let's say you have an image analysis application like I do, but each individual image has some set of parameters you want to run, or you're running a machine learning approach and you want to try it with different parameters. How do you do this with a file full of parameters? I usually either have different files, depending on what the parameters look like. I could have one file that's a CSV and just read the slurm array task ID row from that file and send it to my application. That's one way. Another way would be you can even read it in the application by passing the iterator and having your application read the CSV and get the row out. I do that frequently. Another way you could do it is if you have separate files, you could say read in file underscore SLURM task ID, and they might be named that if they're all separate files. And they might be, I mean, and you might have a data set of 100 images, each with its own metadata file that you have to process.
Yeah, and if you like, if you guys are in those situations, it's always good to come to our office hours.
We've done this a bunch, so
because we have had experience with all these scenarios and have helped a lot of people. So we would be able to help you guys when you're using arrays, and in your particular situation, how you should use arrays as well.
Yeah, and we like arrays for a couple of reasons. Some people have been very successful using their own pre-queuing job submissions. I know one particular user uses it effectively for sure. But we like arrays because they're built into SLURM, they're easy to use. And if you accidentally submit 5,000 jobs all in one go, you might crash the SLURM controller. And we've seen that happen at least once in the last couple of years, maybe more, where somebody inadvertently submitted like 2,000 jobs all at once and the SLURM controller just died. Like you couldn't handle it.
So if you were using array at that time and you had submitted 2,000 jobs, SLURM would have been okay because that's how it has been built. And
because you're not really submitting 2,000 jobs. You're submitting 2,000 jobs that look alike, but not into the queue all at once, right? It's up to SLURM to put them in the queue. And so it will trickle them out based on either this percent number or the maximum allocated CPUs you're allowed, which right now is like, I don't even know what it is right now. Isn't it like 10% of the total or something?
Around
so it should be about 480, I think, ish right now. It used to be about 270. That was that 250 we were talking about earlier. So no matter what, it won't submit so many that it will crash the server, or if it does, or crash the controller. If it does, then that's an us problem. So we'll help you with that.
And I mean, we have another repo where we do talk about all the different types of array jobs and how you can use it if the files are named sequentially or randomly.
And we have a few examples. I have one that does like a design of experiments style approach in Python. Ravi and William Monroe came up with one that's a little bit more straightforward than mine, but there's lots of approaches. I've done it in MATLAB. I've done it in Python a couple times in different ways. Like, so again, if you have a situation where you need to run 1,000 of the same thing, let us know. We can help you get it onto an array job.
And I also posted the link for one of them in the chat. So
perfect.
If anybody wants to know, they can just follow that link and start using it. And like we mentioned earlier, definitely come to office hours whenever you have questions.
Okay, great. So the very last thing that we're going to talk about before we wrap up is how to request GPUs. This is becoming more and more popular. Thank goodness, because GPUs are really, really fast for a lot of different kinds of data. I think most machine learning algorithms and AI stuff benefits 80 to 120 fold. So you, instead of taking 2 minutes to run something, instead of taking 2 minutes, to take 1 second or 2 seconds, right? Or 1 second.
So wherever there is mathematical calculation, the high number of cores that GPU has is super useful. So
it's just hardware dedicated to a certain kind of math, and in that case, at least it used to be just floating point. They've extended it to integers now and single and all this other stuff, but it just goes a lot faster than a CPU, because a CPU has 8 cores for general purpose computing. A GPU has, a modern one has, at least 1,000 cores that are for a specific kind of math. And so if you can take advantage of that specific kind of math, which is a very common thing nowadays, you can make your workflow go a lot faster. And there's a lot of great packages out there that are built to take advantage of it. For AI and machine learning, you've got sklearn, TensorFlow, PyTorch. Keras is, I think, got eaten by TensorFlow, but it is a separate API within their ecosystem. So some of one, some of the other. There's definitely other workflows. I know genomics is starting to get onto this too. There's some packages that are building out GPU accelerated genomics pipelines and stuff.
And some neuroimaging tools have some components. So just keep in mind when you're going through the manuals of the softwares that you are using for your workflow, it might not be that the entire software has been changed into or converted to utilize GPUs, but certain portions, and generally they are the time-consuming portions of the workflow. A lot of softwares, people behind the softwares have been trying to upgrade them so that they utilize GPU more. So whenever you see the word GPU in front of any of the executables for your softwares and your workflow, try to read a bit more on that. That might save you a lot of time when you're trying to actually run the workflow.
Yeah, I mean, 100th time usage for that segment. And so we'll probably, maybe we'll have another user session sometime in the future about this, but there's a lot to parallelization. Like there's a lot of conceptual ideas behind it. Some problems are massively parallelizable. Some are not at all parallelizable. And so that's why only certain tasks in a workflow might be on the GPU, because only those are amenable to running on a GPU at all. Like you could run a serial algorithm on a GPU, but it would be no faster than running it on a CPU. So why bother the extra coding or specialization? So, and certainly there's certain kinds of data you don't want to run on a GPU. Like why would you mess around with file path manipulation on a GPU? That doesn't make any sense. It takes microseconds to run 1,000 paths. So why would you bother? Okay, so, but we can talk about that in more detail in maybe a future one. But in the meantime, so we're going to go back to our hello world. I added a GPU right here and here in the job name and in the file name. And I made one other change down here. I added a little bit of memory because I don't remember why. Probably it's just to fit the Cuda library in there, I guess. And then it makes sense. It's a pretty big library. And then of course, gres equals GPU:1. So gres means general resource. And that's how we've done our GPUs. I think SLURM is building out GPU flag, but that's the point. Okay, so gres is general resource. We're saying give us GPUs, one of them, right? And so if we want 4, and there are up to 4 on a node, we could say GPU 4, or we could say GPU 2 or 3 or whatever we want. But we're just going to stick with 1 so we don't eat up everybody's resources while we're doing this demo. We also need to, for anything built with Cuda, which is everything I listed before, TensorFlow and sklearn and PyTorch, and anything is going to be programmed with Cuda, just about. You'll need to load the Cuda drivers, which is under this Cuda version number /toolcat/version number. I don't know why we have version number twice, but we do. It's just something you just got to deal with it. And so we load that module up, right? So we can do anything with the GPU. Otherwise, we can't talk to it. Without that module, there's no way to talk to the GPU, the NVIDIA GPU.
So one more thing that we need to change is, I don't know if anybody else noticed it, is the partition.
Oh yeah, good point. So we gotta go to Pascal nodes.
So all our GPUs are sitting behind this partition, Pascal nodes. Like the name suggests, all the GPUs are P100. So
oh, actually, that's true. That's why it worked before. Okay, because this did work before. There are, is it 4 nodes with really old legacy GPUs?
Yeah, the K80s.
Yeah, K80s. They're by today's standards, they're not very helpful. We don't advertise them anymore because we don't think you need to use them, and I wouldn't. I would definitely use the Pascal nodes, but you should know that they're there, so you're not going to get any sort of error if you run on Express and ask for a GPU, right? Yeah. You will get the K80, and it will happily load all of this and do the NVIDIA SMI and tell you all about it, but it's not what you want. Trust me, it's not what you want. Those are old GPUs, they aren't great. Do Pascal nodes instead, and then you will definitely get the P100s, the Tesla P100s. Those have 16 gigs of memory. They have a modern CUDA core with like 3,000 cores, modern CUDA CPU with 3,000 core GPU.
Cores. And Kepler nodes or K80s are also limited to 2 GPUs per node. So if you ask for 3 GPUs, then it might just run into errors. So it might not actually run those things.
So bottom line, make sure your partition is Pascal nodes, and make sure you ask for gres GPUs, and make sure you pick a CUDA library and module load that CUDA library. And then the final thing I've added is the NVIDIA SMI. So that's just, I forget what SMI stands for, but it basically gives you information about the GPU's current state when it's run. So things like, well, I'll just run it. So I'm going to cat to a file, I'm going to run the SBatch the file, and then we're going to see, it's going to take a second to load up the module and everything. So that's why it's going to be in the queue. And it's probably done. Oh, it's not done. Okay, give me a second. Oh, now it's done, right when of course. Okay, so here we go. So you can see this is NVIDIA SMI. This is the driver version. So this is the SMI version. This is the driver version, which is how the software talks, the OS talks to the hardware. This is the CUDA version, which is what? Oh, I said 11.3. I wonder what.
Well, driver version is that.
Okay, well, maybe because, yeah, maybe if the driver version is too old, it loads the older. Yeah, okay, that's probably why. So different CUDA versions rely on different driver versions. I guess 460 can't run 11.3, so it fell back to 11.2 compatibility. I mean,
and you can see P100. So Tesla P100.
Yep, you can see the GPU itself is here.
Yeah,
it's running it. It's not running anything, so we expect it to be pretty cool. 32C is pretty about as low as it's going to get in a data center. 25 watts out of 250 watts. You don't care about that much. But here's the other interesting thing. That's how much data is on it. There's no data on it right now.
Yeah.
And
I actually enjoy when I see when you're actually running something on the GPUs and you use this NVIDIA SMI command, you can see the temperature rising and all the
memory fills up and the utilization goes up, and yeah, it's pretty great. And it'll tell you, of course, process IDs running on the GPU too if we have anything, but no processes. I didn't, yeah. So, but when you run it and you have this is also a good way to check if, say, you ask for 4 GPUs, is my workload distributed on those GPUs correctly? When you run an NVIDIA SMI, it'll list all 4 of these with their own separate table, or in this table, right? There'll be 4 blocks like this one. And if it's correct, right, you'll see a distribution, they'll all have memory usage, they'll have utilization. If it's not right, only one will have it. And so that can be a way to debug, hey, is it distributing, learning correctly in an AI application, for example. Okay, so that hits on GPUs. So again, bottom line, GRes GPU and partition Pascal nodes, which I think has a maximum of what, 10 hours? Or is it 12?
12 hours.
12 hours. Okay, my mistake. It'll show up in the list when you log in.
Yeah.
So we've learned a lot this session. So give yourself a pat on the back. There's a lot to pick up here. We learned how to use srun and sbatch, when to use each. Basically, always use sbatch unless it's something really quick, really simple, like moving files around, a lot of files around or something, or an Anaconda thing. We learned how to cancel and review jobs using scancel and saccount and sq, and SEFF, of course, for optimizing job and queuing efficiency. We really, really encourage you to take some time, look at SEFF, get a feel for it, get a feel for what your jobs are doing. It's always good to know, how things are running, and of course, how to make array jobs and how to request GPUs. So, and all this stuff can be used, it has to be done at the terminal, but you can do it over SSH, or you can do it on the web from our Open On Demand terminal, which is how I'm accessing this in the first place, right? We saw Open On Demand over here, right? So this is the Open On Demand interface. Lovely. https://rc.uab.edu. And the link is here, and we can post it in chat. Do you want to post it in chat? Just in case you don't know, if you're just brand new and you're just showing up, you gotta this. I recommend using the Open On Demand. And of course, I'll show you how to get to the terminal. Once in Open On Demand, click clusters, click Shiha shell access. It'll open a new tab, and you'll be at the terminal. Give it a second. Oh, maybe. Oh, it's a little slow today. Okay, well, I don't want to wait here all day, but oh, there it goes. Okay, so now I'm at the terminal, so I could type, sq-u cache user, and ta-da, it does exactly what you expect. Okay, and we of course have the job composer. I don't personally use the job composer a lot. Some people really like it. It's up here under jobs, job composer. We're not going to go into detail on how to use it right today, but basically you can take your sbatch scripts, you can create a new job from a template, right? And we can just say, no, do I just pick one of these? I guess I just, oh yeah, create a new job. That's right.
Yeah.
And so that's from some template. Did I just? Oh,
Yeah, I
okay.
think you have to create a new template, but you can actually just open any one of them and paste your job script
And
over
then
there.
you can just open up, in case that wasn't clear. So job composer, you got a job not submitted yet. You can go over to the folder contents, right? You can say new job or new template or whatever. You can go down to this folder contents, main job.shell, click that, it'll open a tab and you can put your job in here. One thing to be aware of, we have not fixed this issue yet. If you're coming from a Windows environment, Windows ends lines with 2 characters, /r/n. Don't worry too much about the details, but ends it with 2 characters. And that's different from Linux. Linux is /n. SBatch expects only the /n. If it gets /r/n, it will error out and it won't run your stuff. There is a command on the terminal. So now I gotta go back to here. The terminal, I can't see it, so I'm gonna do this. Just gotta open it. So at the terminal, there is a command DOS to Unix, and you can put your file name or file path after that and press enter, and it will convert the /r/n into just /n. That's DOS to Unix. So if you use the job composer, or if you're getting that kind of error, that is how you fix it. That is one way to fix it. I got this bar out. All right. For some next steps, always be considering your next steps, to get to your goal. So it might be worth exploring some documentation. Our wiki has useful examples. Ravi posted a GitLab link. I've got one too somewhere. I may have linked to it in those examples. If not, I'll figure that out. And then, of course, the SLURM folks themselves have their own detailed documentation. I wouldn't start there, but when you're trying to fine tune your scripts, figure out flags that might do something more advanced, this is kind of the place to start with those more advanced things. But I'm going to open up an example of the SBatch. It is very opaque documentation. So again, I don't, it's got every flag listed and what it does, but it's really hard to look things up here. So I don't recommend doing this as your starting point. I just wanted to give you a little taste. I would definitely start with our documentation instead, which is here. Okay, and so we have Hello World serial, which we kind of saw before, parallel to MPI, revisited, array job parameterization, GPU jobs, just, or you can even look at what we've learned today in this Jupyter Notebook as a template.
Yeah.
Yep. And so I think we've covered everything. Ravi, do you have anything you want to add to what we talked about, or any thoughts?
No, I mean, yeah, it's everything that you mentioned, that the SLURM folks do have very good documentation.
It is good.
but it is also very on the point kind of documentation.
It's written with programmers and system administrators in mind, rather than than researchers like us, right? So
so definitely come to us if you have any questions about any of the commands, or you want to know what they do. I mean, at least for most of the general used commands, we would have some idea about them. If there is some command that we don't know about, we'll also have to go back to SLURM documentation to read on it. But it's more like the SLURM documentation by SCEDMD, the people who gave out SLURM, or care for SLURM. The documentation is very pointed, so you have to read every word, because every word means something in the documentation.
Yeah, they did a great job putting it together, but it is a little advanced. And that's not to say, we all can't get there. It's just saying, like, just you kind of have to know the basics before you'll understand. It took me a while to understand their documentation, I'll tell you. So and again, if you run into any issues, or you don't understand something, or you've got a problem that this more basic stuff we've gone over, this first step stuff is not just not meeting what you need for your workflow, let us know. We are here. That is our whole purpose for being. We will love to help you out and get you running.
So are there any questions that anyone has?
Yeah, please.
Feel free to unmute yourself and just ask any questions, or post your questions in the chat, and we'll be happy to answer any questions that you guys have.
We love questions. That's why we took these jobs. I feel like my whole life is questions now. Okay, well, I'm not seeing anything coming in.
Yeah.
Um,
So
We'll hang out for a little bit longer just in case, but I think we're gonna wrap it here.
yeah, and feel free to come to our office hours tomorrow as well. We have our office hours on Monday and Thursday.
Mhm.
Both of them are from 10 to noon. And if you have any questions from now till the office hours, just feel free to join us there and ask your questions there as well.
Okay.